Hi guys, in today's video I'm gonna show you how to connect a plain old button and use the button to turn on and turn off the LED. However, not in the terms of controlling the circuit itself, rather through code. In order to do that, we need the following ingredients. We need LED, resistor and a push button. So to start, we should take a look at the diagram which we are gonna create. Here I have a button, microcontroller. In this case on the image it is Arduino Uno, however we are using SparkFun Photon Redboard. There is a difference, however what I'm gonna guarantee here is that the numbers are gonna be the same. I'm using number, for example, here D2 is going to be the same as a D2 on our Redboard. The button, component button, is a tactile button that is closing and opening a circuit in a diagonal. So if I push button, these two pins are going to be connected. And I'm connecting a button to the ground on one side and to the pin D2, and the LED I'm gonna connect to the D3, and other pin is going to be connected to the ground via resistor. So I'm gonna assemble this circuit. Here I'm gonna connect the ground, which I'm gonna put to the common vertical line on my breadboard, and then I'm gonna use the same LED diode, and the ground side I'm gonna connect directly to the ground that I just pulled from the board like this, and the other side of the LED I will connect to the, as it's in the diagram, to the D3 pin. D3 is here. Also, I need to connect the button. When connecting the button to the board, please be careful not to push it in on the cap. You can actually detach the cap if it's inconvenient to push in. It will take a bit force to push it in, so use your nails to put it in like this firmly, and then you can reattach the cap on the button. From diagram you could see that the button has to be connected diagonally, one side to the ground, which I'm gonna put here, and other side of it should go to the D2 on my Redboard. Simple circuit. What we're gonna do now, I'm gonna read the state of the button, whether it's pushed, pressed or not, and then I'm gonna turn on the LED if it's pressed and off if it's released. So let's head back to the Visual Studio Code. I'm gonna create myself a new project. I'm gonna name it, create a new folder called button, and then I'm gonna name this project button. Create yes. While the project is initializing, would like to save? No. Here I have Ino file. I'm just gonna clean up all the comments so it's more readable. To begin with, let's declare ourselves constants for the pin. Pin LED is D3. I'm missing a type, that's integer. Const int pin button equals to D2. D2. And then in the setup, I will use pin mode PM, there you are. Pin LED is going to be output, and pin mode for the button is going to be input pull up. So why are we using input pull up mode? It's probably determined by the nature of buttons and in microcontrollers. So let me draw you a picture here of what is pull up resistor in this case. So this is microcontroller unit. So this is ground, and let's call this pin here positive, usually VCC. So this is microcontroller. This is probably 0 volts and this is 3.3, but it's irrelevant in this case. And here we have our D2 pin. And what we did in our circuit, we have connected this ground to the D2 using a switch. Whenever we push the switch, we are closing the circuit, and this D2 read of a D2 pin can register, in this case, low, which is 0. However, when the circuit is opened, the D2 doesn't know what is the value. If you would read here, now in this case when it's open, you would probably get a random value, high or low. This is why there is a special kind of resistor called pull-up resistor. It is high value resistor connected to the pin. And in this case, so this resistance here, it's rather high. When we read the value of pin now, it will actually read VCC, which is 3.3 volts, which is kind of high. And when we read value on D2 when the resistor is now connected, because this is the active circuit, because here is disconnected, we will read high. Actually, we will read VCC voltage on a pin D2. Because this is very common in embedded software development, generally in embedded development. They have put this resistor inside the board, and you can actually activate this resistor with input pull up. With input pull up mode defined in pin mode for specific pin. And how will this work? For example, when we close the switch, the resistance of this part of the circuit is smaller than this R resistance here, and this is why we will read 0 volts on this part from this circuit, right? So when the switch is closed, when the switch is down, when we push the button, we will read low. When we release the switch, meaning opening the circuit, we will read high, because this part of the circuit is now being active, and we will read 3.3 on D2. Let's get back to the code and read the values of the button. I'm going to create here on top a variable type bool and call this variable button state. I'm going to set it to low in this case. And just create more space. And the low has to be capital, low, or 0 or false. Whatever you prefer is the same value. And in the loop, I'm gonna read the button state. So button state equals to digital read on a pin button. It will return, digital read will return 0, 1, high, low, true, false, depends, whatever I want. And then I'm gonna check if button state equals to high. I'm deliberately using high instead of zeros and ones and high and low, or true or false. So if the button state is high, this means that the state is unpressed button, or if you prefer, open. I'm gonna turn off the LED. Digital write pin LED. I'm gonna turn it off, set it to low. Else I'm gonna turn on the LED. Pin LED, set it to high. We can cloud compile and cloud flash. In the meanwhile, I'm gonna connect the board to my PC, and so it's successfully compiled, and I'm gonna do cloud flash. TD1 is the name of my device. Let's give it some time. Now it's flashing. It means that it's okay. And the LED is off. When I press the button, the LED turns on. Basically what I wanted. Obviously, if I put the LED in the circuit with the button, you would get something similar behavior, because this is purely physical, and it works. What we will do now, I'm gonna change a bit. I will toggle the LED state. So when I press the button and the LED is off, the LED will turn on, and the next time I press the button, the LED will go off. So toggling the state of the LED. To do that, let's get back to the code. I'm gonna create myself another variable called LED state. I'm gonna set it to false, so I'm toggling this state. So whenever I press the button, I'm gonna toggle the state. So when the button is pressed, it means that the button state is low. I will just remove this part, and I will put here LED state equals to negative LED state. So if it's high, it will become low, and if it's low, it will become high. And after this, I'm gonna write digital write pin LED, and now I'm gonna use the variable LED state. Now, if I flash this code, it's being flashed. If I press the button, you can see that I have managed to turn it on. If I would press the button again, it turns off, but you can see that it doesn't work properly. There, it messes up. And the reason for that is very physical. because if you would disassemble this button, maybe I'll do this one day, you will see that the button is actually two metal plates being pressed together. Because no metal plates are perfect, this contact is not perfect as well. Another reason is because when you press the button, there's a tiny bits of bounciness, maybe on an atomic level, that will make multiple contacts. And these multiple contacts are being registered in our loop here in digital read. It will read the state many times. And this will result in multiple changes. When I press the button once, it works. Maybe and maybe not. Because I'm not sure how many times did it register the button press. There are multiple ways to avoid this. I'm going to avoid this on a software level by introducing a tiny delay. Let's get back to the code, and after the reading of the button, I'm going to put here some delay. Let's say 100 milliseconds, which is a lot, but I hope it will work. So during this 100 milliseconds, no matter how many button presses happens, I will always have a delay. And this will not work either, you will see why. Now it's flashed. If I press the button here, it's the same mechanisms, the same issue, okay? Because this delay doesn't wait, it happens all the time. What I did, I just slowed down the main loop at some point in the loop. What I need to do to make this even better is I'm gonna check if the button state has changed. And only then I will do this delay. Okay? When I say button state, the button state always changes when I push the button. I'm gonna check if the LED state changed. In order to do that, I need to introduce myself a new variable, LED previous state, and set this to false. Okay, everything is false. Now I'm gonna check here if LED previous state, if it's different than LED state, then it means that I need to toggle the LED state, which means that I'm gonna put here this line of code here, and then only then I will put delay after I can do this before or after, it's irrelevant. And then I will store the new state into previous state. LED previous state equals to LED state. It's algorithmic solution that might work. So let's check on the real case in the board. Now the board is flashing. When I push the button, still a bit wobbly. Maybe if we increase this to 300–400, half a second, it means that anything that happens in the half a second, it will not register at all. And now let's check if it works. It's being flashed. And you can see that it's very stable. When I press the button, the LED is on. Press it again, it's off. This delay is used for filtering the data, filtering the events and so on. Of course, you can do this on a hardware level using capacitors and so on, but this is on a software level, and we can do this. It works just fine. In one of the next videos that I'm gonna make, I will solve the same issue using interrupts, when we will learn how to use interrupts for embedded devices. That's it. Thank you for your time.